Over the past few years, we've seen AI move from experimentation into real operational environments. And more specifically, in AI for networking, that evolution is accelerating as organizations move from manually launched scripts to AI-based alerts and AI ops, and now moving towards autonomous or self-driving networks. Hello and welcome. I'm Bob Laliberte with theCUBE Research. Thanks for joining us today for the What It Really Takes to Build a Self-Driving Network webinar. Joining me is Justin Melloni, the Senior Technical Lead from HPE Networking. Welcome, Justin.
Thank you, Bob. I'm happy to be here.
Yeah, it's going to be great. So there's no shortage of AI claims in the market today. What's much harder to find is a clear understanding of what it takes to operationalize AI at scale to deliver consistent, measurable outcomes. So today, we're going to take a practical approach. We'll walk through what we believe are the key requirements for a self-driving network, and more importantly, we'll try and validate those concepts with real examples and demonstrations where we can. Now, today, we're going to cover basically 7 elements, and the first is what it means to be AI native. The next is the importance of real-time telemetry. Next, the role agentic AI plays, the ability to cover highly distributed environments, why policy-based security is essential to building trust, and then review the time to comfort and time to value in creating outcomes. And lastly, we want to talk about the need to have a truly extensible solution. All right, so we want to start with the AI native aspect first, and there's a lot of components to what makes up an AI native architecture. So I thought we should run over and have a discussion about what some of those things are. I know one of the first things, everyone knows AI has been around for a long time, right? If you watch Jeopardy, it was like 13, 14 years ago, right, where it was a contestant on and won the event. But there's a lot of things that have happened since then. I think one of the most interesting pieces that organizations, when they're talking about AI native, they want to know how long have you been doing this, right? So maturity of your solution is something that a lot of people will ask when they're going through an evaluation. So that's certainly going to be important to have. Another piece of that is that it's not focused on the devices, but on the experience is another thing that's a strong attribute of what might be an AI native environment. And then I think, the need for it to be extensible is also really important in this architecture. And so from a networking perspective, that means not just one domain, but being able to take all of the domains that are in the organization, right? Going from the data center to the campus and branch, to the WAN, et cetera, and make sure all that's covered. And then I think the other piece is that, another aspect of that is to make sure that it was not something bolted on. You hear about this a lot on the security side, right? It needs to be built in, not bolted on. But I think that's true for AI as well. When you're trying to develop AI, it can't be something that you've just attached to a monitoring program. It really needs to be something that you've built from the ground up, and like I said, is extensible and is able to look at and deliver those experiences as well. And I think another big piece of this is something I always refer to as having the time to comfort with this technology, because for some, AI is kind of scary. And so that, I think, comes by having that closed loop intelligence as well, so that as you're developing it, as you're working with it, the system is being fully transparent. It's letting you know what's going on. It's letting you know what it did. And it's giving you an active opportunity to participate in and validate what's happening and what's going on. So I think there's a lot of things like that would really help define what that AI native architecture is. And I think ultimately all this comes down to is that it's great to have all these capabilities, but at the end of the day, it's all about the outcome. And so does your AI architecture, when you implement it, does it make you more agile? Does it make you more responsive? Can you go to being proactive instead of reactive and things of that nature? And I think that's really key. I think, making sure that it's collecting all the data all the time is going to be another important piece. And so that telemetry and so forth. And then I think also, how organizations actually come up with and develop, the capabilities to be more accurate, right? So that long-term model training versus just sort of reactive analytics and things like that are going to be important for people to understand. I guess for you, as I think about in your role, how should enterprises really evaluate whether a platform's truly AI native versus just AI enabled?
Yeah, no, I think every point that you said is accurate. First, I want to look at, we're currently in an AI gold rush, right? I see, my laundry machine has AI on it, my, pens, all those kind of things, they say AI on them. But what does that really mean? And that's kind of the bolt-on aspect that you talked about, right? I used to, in the security side, I used to call it like painted on or whatever, right? It wasn't built with AI as its original intent. Yeah. And that does matter. And it's going to matter a lot, and especially some of the points that we'll make later, because the tools that are all talking to each other, that are all making this predictive or proactive suggestions, they need to communicate. And if you're just putting one, like we said, like bolt on onto one device and another device, it's not getting everything. Yeah. But over at HPE, and originally through Mist, and Juniper acquired Mist several years ago, and then HPE has now acquired Juniper, that was always the intent. They built a product. Originally, the idea was to have access points that were controllerless. And then from there, in order to do that, you had to be cloud native. We had to build it up in the cloud. And that enables for a lot more compute and a lot more scale. And once we had that, we're able to then bring in all of these kinds of, what back in '08 we used to call DevOps, right? And combining the developer skills, the scripting, with the operations.
Yep.
AI is taking that, or AI ops now is taking that to the next level where we actually build in this automation. So when products are built that way versus ones trying to now claim to be AI, even though they weren't 5 years ago, but because of the gold rush, that's the difference between AI native and not.
Got it. No, I think that makes a lot of sense, and hopefully people can understand that and use that as criteria when they're evaluating. I think having the right architecture is super important, but as we know, everyone lives in a really highly dynamic, modern environment. It's really important, as we mentioned earlier, to have that continuous monitoring or observing what's actually happening in that environment. So why don't we talk about the next requirement, which is continuous telemetry, and more importantly, maybe understand how that impacts the experience as well, not just infrastructure metrics. So can you walk us through what that looks like?
Yeah, definitely. And before I jump into the demo, I'll just kind of level set a little bit. When we're talking about continuous telemetry here, we're talking about constantly learning, right? You've used LLMs nowadays, large language models, and you've probably experienced hallucinations, all sorts of other things like that. What's great in an AI native platform, or actually even take that step further to a self-driving platform, is that it is constantly learning off of the data points on the network. And going to your extensibility point as well, it's not just from one device, right? If we bolt on AI onto an access point, okay, we can now understand what that access point's doing, but we need to know what's the access point, what's the switch, what's the WAN, what are the clients on the other side doing? You bring it out to security, what are we doing as far as our firewalls, et cetera. So by having that closed loop or that continuous learning, every single point, every single data point that comes on the network, we learn from. And on top of that, if you can extend that out to your third-party vendors, for example, Teams and Zooms and stuff like that, then you can get even more granular data. And when it comes to, really what's the whole goal of all of this, you mentioned experience first. So for example, the experience of the network operator, they can know they're having a good experience because they're troubleshooting faster. So let me show you what that looks like in real life, though.
Yeah, let's take a look.
All right. So in this platform that you're seeing now, this is our Mist platform. Right. And our AI engine in this we call Marvis. So when we click over to the Applications tab up here, we can see what's called our LEM, or Large Experience Model. It's different than an LLM, but the name's kind of similar. But what an LEM is it's taking all of that data, like you said. So every time a user logs onto the network, it doesn't have to be a user. Every time a device logs onto the network, we're collecting 150 data points from that device. We're collecting information from the access points. We're collecting information from the switches, from the WAN edge, from wherever it goes, the application. And we mentioned Team and Zoom applications. Those are all brought in here into our LEM so that we can then use that to figure out where the problem is. So
So in that case, if you were working in network operations and you noticed a problem with Zoom or something like that, you could proactively fix it before it impacted the call, before users started calling, opening up tickets and so forth.
Exactly. That would definitely be one really good benefit of it. But even, like, let's be honest, like, while that exists and is awesome, who has time to proactively look at things, But we can go through here, and we are implementing the Shapley algorithm. And through that, we are able to tell why we had a particular issue, right? It breaks down each user minute into whether it's a good minute or a bad minute. And then through that tells us where the issue was, what could have been the cause for that problem. So that's the benefit of having that continuous telemetry and experience brought into your platform, into your AI native platform.
Excellent, excellent. And do you find, like I was talking earlier, do you find that because of that, organizations are more proactive?
They do. They get more time. I will still say, like, again, we definitely find that organizations are hiring less IT people. Like, the budgets for IT is smaller. So it's kind of, a zero-sum game.
Got it. Well, certainly having that visibility is going to be foundational, but I think it gets even more interesting when you're able to act on that intelligence. And so that brings us to our next topic that we want to bring up, which is probably one of the most talked about and buzzy areas in the space right now, which is agentic AI. So it's, how does agentic AI actually help organizations and their networking environments? Can you show us some tangible examples of how an agent actually operates, maybe what triggers it, what actions it's going to take, and how the validation happens?
Of course. Let's start off here. Again, our Marvis conversational interface, our LLM. We can start in here. We can ask it to troubleshoot any of our sites. Right? We just say troubleshoot, and the site here is called Live Demo. It's just the name of the site. And what Marvis is going to do is it's going to go out and ask the other agents what's going on, because they're the experts in their domain. So the agents for the other sites, the agents for the different access points. And what's great about the way that Mist does it, and HPE as a whole, is we start using explainable AI. So a big problem that everybody has, especially with hallucinations, is that you have no idea what's going on. You don't know the data set. You don't know where all that information came from. And now you're given an answer. You're supposed to just trust it, right? With explainable AI, we will now actually tell you, these are the different agents that we've talked to. These are the different devices that we talked to. You can go step by step and see each and every query. And then you get your results. And you can trust your results. And it explains why it came to that particular result.
So Justin, that's pretty cool. And I love the transparency so that the end users can actually see what's going on and it's explained to them as it goes through each step. How long does it typically take for end users when they're using this to get comfortable and to really trust what it's doing before they are able to let it go more?
Yeah, no, that's a really good question and point. It takes, obviously, everyone different levels. Yeah. And what's great with our platform is we enable each of those different levels for you, right? So first it starts out, and people don't even realize they've been using AI forever. Again, it's just kind of how you reframe it. So it starts out with us showing you the different metrics, the different things that are measuring your network. How, again, we're experience first, so we want to measure our networks based on how the end users are enjoying it. Are they able to connect to the network? Are they getting kicked off? Why those things happen. And then from there, you start to transition into the actions, the recommendations. Like, hey, we've seen these things. Again, we provide evidence to support why we believe a certain thing is happening, but that's up to you to make the change. Eventually, as that trust starts to build, they say, you know what? I will turn on the self-driving action. And so some examples there might be a stuck port, right? Like if a port is stuck on your switch, you want to bounce that right away. It's literally doing nothing for you when it's stuck. Yeah. But if you need a human in the loop, then they need to get the ticket, and then they need to figure out, and they need to bounce it and verify and validate that it's done and everything. Again, no benefit to waiting. So if you can trust your AI to do that for you, and it bounces it for you and then validates it and says, this is fixed, there's no problem there.
Yeah, and I think that's an important point though, because for a lot of organizations, it's not binary. It's not all or nothing. You can go through on a case-by-case basis and be able to enable that automation to occur on your behalf. And so again, once you've gone through and seen it, trust it, then you can turn it on. All right, well, that was great. I think all of this is great, but the hard part is, it becomes significantly more complex when you start talking about an end-to-end environment, right? When you have to go across multiple different domains. So, and as we all know now, especially in the AI era, modern environments are highly distributed. So you're dealing with things in the data center, maybe the cloud, the edge, and so forth. So I think we want to talk about next is the ability to operate in a unified way across that distributed environment. How important is it to extend beyond one domain in the network to maybe across the entire distributed environment?
I think it's extremely important, right? And I think it's not an option you get with a lot of your vendors. So you need to have a platform where all of these different devices are talking to each other. We talked about Agentic AI and all the different agents and everything. And so it's only a couple years old. It's only 18 months old, but there's a protocol out there now called MCP. And MCP is used to have those agents talk to each other, and then you have your LLM as your central point. So if you can have a vendor that has the devices talk to each other so that they can then again pinpoint where the problem is occurring, then that saves you so much time, right? And so this can extend, we talk about the access points, for the access points getting the client's connections, the switches to connect everything from there, the WAN side, going out into the internet and be able to connect, and then the application. And that stuff I think is table stakes. Okay. We can even go further and we can go out into the data center. We even have our WAN set of products as well, where we've brought in our same AI technology. We brought Mist and Marvis into them to then enable that throughout your whole network.
Yeah, because I can imagine that, certainly for everyone out there, they're all dealing with multiple different domains. And so having that context, having that unified management over that entire environment, having the AI cover all that space and know and be able to provide that context and be able to show it and be able to validate that very quickly is going to significantly accelerate troubleshooting. So they're not pointing fingers at anyone, but they're able to quickly identify and be able to go and fix a problem. In some cases, potentially even automatically.
Exactly, right? They're not pointing fingers at anyone, they're pointing fingers at the issue now, right? It's no longer, it's a security team's fault or it's a networking team's fault or anything like that. We now have the evidence to say, no, it was the application, it was this particular port, it was, whatever's going on the network at the time.
Okay. And is there anything special that you guys are doing that helps to ensure consistency across those multiple different network domains?
I think that's where our MCP servers come in, right? So each of these devices kind of talk to their centralized MCP server and then validates the information that we have there.
Okay, cool. So I know as we expand over these environments, one thing really becomes non-negotiable, and that is trust, right, and security. And so I know it was a big theme at Davos around AI to be able to have that. It's really hard to have that level of autonomy without having the appropriate security and governance. So how does security get embedded into a self-driving network?
Yeah, so there's obviously several different ways, but the way that I think of most is through the authorization, the authentication, the authorization, through your NACs, right? And if you have your self-driving network and you have a NAC that is incorporated within it, just like we do with Central and ClearPass and we do with Mist and Access Assurance, that can then use the information that it sees to, one, validate the user, and then two, a big concept, and you probably hear this all the time, is zero trust, right? And zero trust initially means when a client or when a device gets on the network, we don't give it any access to anything. And then it starts to gain that access, and you create through easy configuration of policies. You tell how it has a permission for what it has permission to. You don't want every device on your network to have permission to everything. Now, the other part of zero trust that people don't usually talk about is when it loses that access, being able to take that access away when it let's say, misbehaves, right? A bad actor jumps onto your computer because you clicked on the wrong email or anything like that, which I've never done, I never will do.
No one's ever done that.
No one's ever done it. I pass those tests all the time, I promise. But when they get on my computer, and then they now have access to everything I have access to. So if you have a self-driving network that can then, again, through all of the information that it's gathering, figure out that this device is not well, it can immediately remove its access entirely, or a lot of times we see them put it into a honeypot.
Mm-hmm.
And then from there, it's quarantined, evaluated, and then hopefully cleaned up. So the self-driving network brought into the security side is being able to respond quicker to vulnerabilities.
Got it. No, that makes a lot of sense. And I like the idea. I assume that policies are all done centrally and then distributed enforcement in all of the different domains. And so is that how you're I'm just trying to think about for those at home, right? You're going in, you're setting the policies, and then will it go across just the domain they're responsible for, or will that extend across to all the domains that are currently under management?
Across everything, right? You probably hear nowadays about Universal ZTNA and SASE and all this other kind of stuff. It used to be we just gave permissions to remote workers that they could use the VPN to get home or to get into the network. But now we have real identity management, and it's the whole network. And I'll just add one other thing to that is IoT. You have headless devices out there. You don't have a way to get in and configure it and say, oh, this device is so-and-so and here's its password. Instead, you just through whichever fingerprinting that's done, again, every time a device jumps onto the network, it's fingerprinted. You can then figure out which permission group it gets.
All right, Justin, let's bring this back to what matters the most for a lot of organizations, and that's that deriving a better outcome, okay? We know that one of the biggest gaps that organizations have is between buying something and then getting real value from it. So I wonder if we can spend some time talking about, maybe, how quickly customers go from deploying these solutions to actually getting real value and real outcomes from them as well.
Yeah, no, I think a big issue, again, comes to what you brought up earlier about the trust, right? So again, just using my own personal experience with LLMs and stuff, the hallucinations can bother me. So I don't want to fully give up control of things to that. The great thing for a self-driving network would be to be able to transition into that. And what's great with HPE is we really do help you do that, right? First, we work with you on a POC to get you to that point where we've already set up your network. So now your network's there, and again, you're getting that telemetry. So AI is working now, but it's not full self-driving yet. You're getting the telemetry. You're in this case, the AI is telling you where the problems are and how the user experience is. That's our experience first part again, but it is not solving the problem for you. As you start to feel comfortable with it, because your clients, your customers, your employees, they're going to feel a lot better because their network is running better. Then you start to look at, can I actually proactively solve things? Right? And through the proactive. So that's, again, taking all these data points and saying, hey, we think, what they call anomaly detection, right? Your normal behavior is this, but we are noticing something doesn't seem right over here. So then you say, okay, and you start to look at it and you fix it. After that, you then start to say, you know what? It's been right all these times. This doesn't look like an issue that if I let the AI resolve it itself, it's going to cause an outage, it's going to cause any problems. So you transition into that. And then finally you say, you know what? I can do this. I can start focusing on other things. And I'll add one other thing into this. We have what we call our digital experience twin, Marvis Minis. And Marvis Minis will actually test your network when you're not even on it.
Okay.
So it tests the network, it goes out, and so that the main idea was, so like for example, you're in retail and you don't have people working the night shift. We can know if there's a problem before the store opens the next day.
Yeah, absolutely.
But that's another data point for our large experience model. So another data point you can then use to know, I trust this with my network.
Got it. And when you're talking about that transition and that evolution of trust with the solutions, are we talking about days, weeks, months, years? What are you seeing your customers? How long does it take someone to get comfortable? I know with just some of the AI ops functionality, the story I hear from your customers is typically, well, we got this alert on a Friday night and we didn't trust it. So we went through 48 hours of troubleshooting, and then at the end of the weekend, we found, yeah, it was right.
Exactly.
And so I know it takes time to build up, but for everyone who's watching, what's a normal expected time frame to start getting adopted and starting trusting?
Yeah, I think what's great is because you can enable it for some things and not others,
Right.
It can be days. Right? And the story you just gave is literally the catalyst that starts it, right? Like you start out, you say, don't trust it. It saves your butt that one weekend. You don't have to stay up late on a Friday or things like that. And then you say, you know what? I'm going to keep trying this in other areas. So it could be days, it could be months, but it's the tools are all there. So it's really just about the person doing it.
This has been a great conversation. Really appreciate it. Hopefully all of you are enjoying it out there as well. I'd like to close our last topic to talk about what the future is going to bring. As we look forward, we've been talking a lot about networking. A lot of people want to talk about full stack, which obviously means more than networking. Juniper has now become part of HPE. You've got access to a lot of other tools and capabilities and so forth. What does the future look like for organizations, that are leveraging this technology, and what that might mean not only today, but tomorrow as well?
Yeah, the future, it looks like third-party devices working together. It looks like extending the agentic AI past one vendor, right? So we mentioned within HPE, you have your access points, your switches, your SD-WAN, your data center, your WAN routers, your firewalls. But that's all networking things. What about if we start to bring in our ticketing system? What if we bring in other devices that just HPE doesn't frankly sell, and then you can start to incorporate that. But even actually taking that step further, looking at what HPE also sells, we have compute and cloud as well. So you have Morpheus for your IT ops and your virtualization, and you have OpsRamp, and you bring in data from that, and now you're getting a more holistic picture of your whole network. So the future looks like all of our devices talking together, being able to help you troubleshoot your network, get to mean time to resolution or mean time to innocence much faster, and be able to work with the resources that you have.
Got it. Yeah, so the real question now isn't so much, should organizations adopt these technologies? It's more about how quickly can they adopt these technologies so that they can get these consistent, trusted outcomes that really impact their business in a positive way.
Yeah, no, 100%.
Hey, Justin, thank you so much. This has been a great session. I've learned a lot. Hopefully all of you have learned a lot. Really appreciate you taking the time today, and hope we can do it again soon.
Thank you so much for having me, Bob. This was really fun.
And thank all of you for joining us today. For more information on autonomous networking, please visit the HPE Networking website.